Hello, everybody. We will talk here about modular monoliths and DDD principles. What you have to not expect from this talk is all the theory, in particular all the theory about DDD, because we want to just see the code and how we implemented an example based on how we use modular monoliths and the library that we chose to implement the DDD. Who are we?
Hi everyone, I'm Mattia Ciriolo. It's my first time here at the Spring I/O as a speaker, so I'm a little bit excited for that. I'm a TOGAF certified architect and an enterprise architect in Adesso, and I basically love well-written code, I love quality, and I have been a Spring software developer for more than 10 years. And
okay. I'm Gregorio. I work in Adesso too, the Italian branch. I'm an enterprise architect too. I'm a Google developer expert on the cloud platform, in particular for everything that concerns the modern enterprise architecture. And I lead the GDG Pescara in my town. Okay, let's start about something that will introduce the code that I promised you at the start. So let's talk about microservices. Let's understand what is good about microservices and what is not really good about microservices. Okay, first of all, we have autonomy. Every microservice has his own autonomy. We have a lot of scalability. A single microservice can scale horizontally because, you know, it's just small, micro, and you can start to replicate it. Resilience, it should be, in a good design, it should be resilient, a single microservice. But we also have a complex orchestration needed. In a cluster, maybe, okay, we use Kubernetes, maybe, it's still complex. No matter how you put it, it's still an orchestration that is needed to, you know, make everything work and work together. We can have network failures. It happens. Imagine just a distributed cluster, and you know you have to have replicas and fault tolerance and so on. And we have a tight coupling via sync calls, and that's something that we should try to address every time. Also, distributed transaction and the observability puts some overhead to microservices. The opposite side of the coin, monoliths. So we are using microservices because we started from monoliths. So if we are using microservices, maybe we understood at a certain point that monoliths were not good or really good. So why we chose to start using microservices? What were the good things and what was the not so good things about monoliths? Well, they're simple. We can debug them easy because you know you have the whole application in just one application. But still, they are tight coupled. It's not clear, the ownership, it's not clear because, you know, you have everything in just one place. So the code starts to, it could be okay and clear, it could not be. It's not inside the design how or who has the ownership of something. And we have fragile interdependencies among every single part of a single monolith. Okay, so we've seen that both the approaches has some good things and some a little less good thing. What we are trying to do with the code that we'll show you, we are trying to take both sides and take the good things, good parts of both sides, using a modular monolith. Oops. So maybe we can take the best of the two worlds, microservices and monoliths, and create something that has internal modules with strong boundaries. So we don't have tight coupling anymore because we have a boundary. We want to try to create something that should be maintainable, testable, understandable, and not also that. We want to achieve that with a maintainable, testable, and understandable architecture, and it should be documented. And that's something that we can ensure with the tools that we'll use and see. Whenever we need, with a modular monolith, we can choose to take it and evolve to microservices. You know, when the project starts, when the application starts to grow, it still lacks something. It still becomes complex, and we will, from time to time, need to switch to microservices. So they're not evil. They just have some pitfalls, and we need to understand them, and we need to choose the best architecture, the best tools for our need. Okay, what we used to create our modular monoliths. We used Spring Modulith, and the Spring Modulith, by documentation, allows the developers to build well-structured Spring Boot application. What I want to, so you can read the documentation for everything, but what I want to let you see here is this part, because the modules should be driven by the domain. Okay, so we want an application, we want to create modules. Let's say we imagine an application for this conference, so let's say the single session and the attendee. The single session should be a module, maybe. The attendee should be another module, maybe. I don't know. What's the driver? What drives me to decide what's inside a single module and what should be outside that single module? Well, Spring Modulith says that the modules should be driven by the domain. What does it mean? Okay. Driven by the domain should let us think about domain-driven development. Theory not included, but we will have modeling bounded context. We will enforce boundaries in our code, and that's something very interesting because, you know, it's not just I decided to have boundaries. It's not just that. I will enforce boundaries. And we can leverage events for both intra-modules and inter-modules communication. That's something that will help us when we want to evolve as a singular modular monolith to microservices, because, you know, every communication is already done with the events. For the DDD part, we chose JMolecules. It's a library that help us to work with DDD. We will see it in the code, and just to start, I talked about code. Okay, let's see the code. First of all, this is our application. So as you can see, it's still loading because we are starting from almost scratch. Okay. The first thing that I want you to see is the POM XML, because we have the dependency from Modulith and the dependency from JMolecules, DDD and events. In reality, we also have layered architecture because we will see that our architecture, we chose an architecture, we chose a layered architecture, and we enforce it. So we test it, we enforce it, we document it using something that JMolecules give us together with Modulith. Okay, what's inside this project as for now? We have just an application, and we have a session that should be our first module. What's the entity? We just want to handle a session, and this is an entity, just a simple entity. We have a repository, easy. We have a service, and also we have a controller, a very basic controller. Okay. What we want to see right now. First of all, you can see that, let's get back to here. You can see that this entity is not a DDD entity. It's just a Jakarta persistence entity. So it's just something that maps the entity to the database. We are not using DDD, but we should use. So we chose to create a module. We chose to maybe put the session in a single module, but we are not enforcing DDD yet. Spring Modulith suggests to use DDD, so why not? Write a test that can ensure us that everything that we put inside our application respects some boundaries and some rules that we decide. So we design an architecture, we describe it in a single test, and to do this, we have, as you can see, ArchUnit and JMolecules that help us to describe the architecture that we want, and the single test should just say, okay, you are not using DDD, so it should fail. Okay, as you can see, just one of these tests is okay, but the other ones are all failing. So elements should be in correct layers. We are not putting them in correct layers. Enforce bounded context isolation, for example. So we wrote a series of checks that we are not yet implementing. So let's switch to another revision. So let's start working on our code, and let's say that our session module and boundary change to, first of all, infrastructure, persistence, and you can see the session entity is here because we have something totally different. We are starting to design it in a DDD way. So we have an infrastructure, we have a domain, we have the session here, so the aggregate root of the DDD. We have the identity intended in the way of DDD. We also have, for example, this price that is used here, but as you can see, it's not inside the session entity, and oops. No, it's inside. Okay. But okay. We also have the application and presentation API. The session controller is moved in the presentation API. This kind of architecture, so application, config, domain, infrastructure, and so on, is everything that we put inside these tests. So we are checking that everything that we write inside our application respect that kind of architecture. Let's find out if the code is okay right now. Okay. Everything is green. Why this is important? We wrote some rules that checks the way we are writing our code, so the architecture of our application, and basically we are saying that our tests ensure that we are writing the code in the way that we designed it. That's something that is self-documenting, because when a new developer joins this project, this application, where do I put the entity? Okay, whenever you want, just try out. When you execute this test, if you put it in the wrong place, it will say that you done it wrong. And that's something very powerful. So it's self-documented and helps us a lot to understand how to go on writing code. Okay, Mattia, I leave it to you for the next layers.
Thanks. And yes, so basically we are saying that we are able to enforce some way or to guide, to provide guidelines that are written in our code with tests that we can use in order to test our further developments, and also in order to teach how people can read the same, can write the same code in the same way. And we can test it, for example, using a use case that we have, not here, in the application, we have a find session that is a use case, and if I put here, for example, a dependencies for a service that is not JMolecules service, but it is Spring service, and I run the test again, it should say that there is a problem. And the problem is that I should avoid to using Spring services in my application layer. And we can a little bit more in detail see how is it enforced. Basically, we have this package info.java that has this application layer annotation used to write our tests. So when we find that in the find session class there is an annotation, and this annotation is not compliant with our structure, with our defined structure, we raise an error. And again, we can move on. Showing one interesting thing. This is from JPA. So we implemented the mapper, basically, that translate automatically, without writing any code, our session to our session entity. And here we have how we have the persistence concerns. So how these value objects or identifier that are all invariants, for example, title, for example, also speakers, is used by our code. And we can also run it, and hopefully it will work too. Okay. And now we have the session today with all the speeches, and the speakers are, of course, anonymized because of privacy, but we have also price, and we can search. So we implemented a little bit things interesting. For example, crafting. Yeah, this is the conference we are attending now. And we can also, of course, create something more. For example, the change price, it was supposed to be a little bit more like coding, but we have a lot to show, so we will move like that. So we now implemented another use case for the session that is change price. And here we have always the same structure. We have this use case that has this change price and use a session repository that is a repository, a JMolecules repository, so a repository intended by DDD, And we have all the defined interfaces for our repository, and this repository only return our aggregate, our root aggregate. Our root aggregate is who defines the boundaries of our transactions, basically. Is it responsible to grant that all the changes happens there? And when we implement this change price, we basically have this method execute. We find a session by ID, and we use the method that is inside our aggregate root, change price, and all the controls about the validity of the operation that we are doing on the aggregate should happen here. So if you pass a price that is null, so yeah, probably you have to define a more descriptive exception, but the price basically is a value object that is auto-validating. So if you have a price that is not null, this price is also greater or equals 0. And this is, oops, this is really, really powerful, because you can just trust that the objects that you are passing, the instances that you are passing to your aggregate, if they are not null, they are valid. And this is granted by the value object itself. And again, yeah, coming back to the change price, yeah, probably in the session, we have also this register event that basically says that the price is changed. The price is changed, and it's a register. So what happens when the JPA persists the entity related to this aggregate? It is responsibility. This is the magic of Modulith and Spring. It is granted that you will have an event published as soon as the transaction commits. This grants you the transactional outbox pattern out of the box. That is something that is really, really important when you have to leverage both on persistence and events and external events, because you have at some stage at least to have the eventual consistency. And we can see also another interesting thing here. We have defined it more or less. We have several kinds of event listener that we can have. This is the basic one. This is an event listener that is transactional. So it is synchronous and transactional. So if you run your code in a transaction, this event handler will run in the same transaction. And we will see that if something fails here, all the transaction will be rolled back. We have the application mode. Probably it's better to show this one. The transactional event listener, that is another kind of listener. I'll document it because it's interesting to see. Yeah, that does basically a transaction phase. The default is after commit, but we have also before commit, we have after rollback and after completion. That means that it runs even if the transaction is rolled back or is committed. And yeah, we have also other interesting thing here, but I would like to show this one that is basically a transaction listener, a default transaction listener with async run, and transactional propagation require new. It means that every time you have an event and you use this application module listener, you can at least have, at most, have eventual consistency. So it is not granted at all that this event will be sent as soon as you have the event. but you can handle it in the future, so you will have at most eventual consistency. And the transactional event listener can work with before commit and after commit. That is basically the synchronous version of the same listener. And yeah, we can try what happens if, because I would like to have only a listener. The structure is okay, and I'll rerun my application. And switch here. So now I can change the price, for example, for the very first session. And here we see that we received an event, price changed event with session and new price and blah, blah, blah. We will use these events later on, but for now, I would like to show you something interesting. If I here throw new runtime exception, okay, simulating an error, and I rerun it, and I reload this one, and I change the price again. Okay, I have this fail to save. Okay, the interface is just for playing around. It's not really good, but it's just to play around. And here we see that, not here. Yeah. Okay, we have this runtime exception with this simulating error, and the price is not changed. This is interesting because we are running. This simplifies a little bit of things because we have this event logger that is defined in event logger application, and we are in another different module that is session. We are generating an event. So we changed the price of the session. So we generated this new event, and in another package, we can leverage the Spring transactional model to roll back all the transaction. This is really, really handy for simple cases, of course. Someone can argue, and I can agree about that this is not really, this is make things really entangled, but at some stage, you have to decide what is better for you, and you can opt for simplicity. So it's your choice to decide which approach you can use eventual consistency, and then you can use Spring Modulith capabilities in order to retry, to republish the event. And I would like to show this one, and then I move on. Okay, so, maybe I'll generate an exception here. Okay, and I run the application again. All right. If I change the price, this succeeded now. Why? Because but the runtime exception is here. So what happened? We said it. We said that this run after the transaction commit. We can see it again because it is interesting. After the transaction commit, and it requires a new transaction. Okay, so this is something that you could use, and I suggest you to use to have eventual consistency, or for another use case that I will show you afterwards. But let me stash a little bit of things, and yeah. let's go a little bit in the future because we don't have too much time. So let's see what, probably from here is better. So I'll rerun the application again. We can, of course, run also the tests, but let's do like that. So we now have an attendee. We can choose an attendee. We can, of course, search for a session as before. I can add an item to my session. I can't submit the order. Yeah, maybe I should, but I can't submit the order yet. I can try to add another item, the same item, and this is a rule that we can see in our aggregate route. We can't add the same item to our cart. This is a domain rule that we invented. And now we can change the price. It is for discount. And we see that here in the order summary, because I have an opened order, we have a price updated and total updated. You can say, yeah, you know that you changed the price here, you had a callback, and you just updated your user interface using JavaScript. This is not the case. Of course, it's possible, but we used another different approach. But let me show you a little bit the order again. No, the new order, because it's a new class. It is an aggregate. I'll close. Thanks. OK. It's an aggregate route. Again, it's a final class, so we can't extend it. It extends aggregate route with domain events. That is our class. We don't have Spring dependencies or library dependencies in our domain and in our application. This is a choice. You can choose elsewhere. It depends on your balance that you would like to take about simplicity of what you implement and about the, a little bit more adherent way or write code in DDD. But I'm not against the one or the other. It's your choice. And here we have that method that we'll use afterward, that is check modify or throw to complete the order, to cancel the order. So we have this order status that is changed only. This is really, really important in the aggregate route. We have also this add item. And the add item receive an item ID. We can see this. This is ubiquitous language that you can use, and what you use in a bounded context. Oh, I didn't show you the bounded context thing. I'm really sorry for this, but it is here. So here we are in the base package Net Spring I/O conference session, and we have this application module that for now, this is right. The session module doesn't depend on other module in our application. This empty brackets means that you can't basically use other model, and this is Modulith. We didn't do anything. This is Modulith that provide this module structure and this bounded context session. This is what let our tests on DDD structure working with the other, of course, because we have this bounded context that is from JMolecules, and it means that in this bounded context should expose only thing that you would like to expose, and you have basically two ways to expose thing in Modulith. And I should have here exactly. So in the base package, everything you put in the base package session, it's exposed to other modules. Otherwise, other things are not exposed at all. But you can decide to expose something to the other modules. For example, we have the domain, event, and here we have a package info where we have defined a named interface. That is the other way to say, hey, the classes that you find here, price changed event from the session aggregate, they can be used by other. And we can see the match here in the order, because the order module depends on session, and session comma, and domain.events. This is the way how we can reference. This is a named interface of the module session, so we have this reference here in the order package where we can use session and we can use session domain events. If I remove this one, and this is something I can show you, is it restarting or? Okay. Good. So, module order depends on named interface session domain events. And our application doesn't run because we have this in the Spring Conf. This verification. Usually people make this verify in tests. It means that if you run your test, you see that the application doesn't run, but this verification prevent that you run your application when you are, for a mistake, for example, going in another environment, I hope not in production, with these kind of things. And you should have pipelines, of course, that test all your code base, but we know could happen. And another thing that we implemented here is something that log all the module structure. And it's better to show you here when it works, probably. Okay. All right. So we have a registered module attendee, we have a registered module event logger, a module internal. All right. There is no a simple way to exclude module right now. So to say this is not a module in the Modulith, I'm looking for it, and I saw that in the community also. Yeah, there is some request. And we have also this order, this session, module session with domain events and the module shared. So we can inspect also the structure here, but we can do something that is more visual in the future. Okay, yeah, more or less 10 minutes. I would like to show you something else, just to a little bit explain. Oh no, I discarded, but it's not a problem. I'll show you later on. So, what I would like to show you is that when we have we have also several domain events for the order. They are not exposed yet because they are not used, basically, or even better, they are used for a thing that I'm going to show you now. So, we have this price changes listener. That is a use case, and basically it receives all price changed events from the session, as you can see here, from the session domain events, and it retrieves the pending order having item, and for each it uses update price. That is a method inside the aggregate. As we said before, everything that changes the state of our aggregate should pass for the aggregate route. This is really, really important. And what is the advantage? That you can go in the order and be sure that everything that change the internal status of your order is here. It can't happen outside. And how? For example, here we have these order items, and we have get order. Yeah. No, we removed it. Never mind. So I can show it. If we create a getter for
maybe
get items,
next revision.
List copy of. We are returning a list of items that basically are, if it works, a final class with all attribute final, so we can't change the state of this item from outside, so we can just create another item, we can replace an item, but we can do this only in the aggregate. And when we get a list of this item, it is a copy that is not mutable. This is really important because if you know that if you return an array list, for example, someone from outside can modify your internal state. And this is something that you don't want. And yeah, but this is not what I would like to show you. We have this price change handler, and we are saving all this pending order. And when we are modifying this, if it's modifiable, of course, because it can be modified if it's pending, then you have this replace all item that matches the condition, of course, and then you register this event order price updated events. Yeah, probably if I close this, it's better. And if I updated something, then I register also the event order total changed event. And I have this get total that is here, and is public, that basically recalculate every time the total. And what I send back is the right value, of course. So we can see who used this. Yes. So we have this event notifier. This event notifier that is a price changes notifier that implements this application listener context close, because we have to close all the SSH emitters before before closing our application, else it stacks for a while. And we are using server-side event to send changes that happen to our order. So this is totally decoupled. And here we can see that we have this application module listener that is asynchronous, as we said before. Yeah, I don't really care if the front end will be updated. It's not interesting for me that it should happen in a transaction. if the front end receives the order, it's okay, or the new item, or the new price for the item, or the new total, it's okay. Else, if I refresh or if I submit, of course, I use my aggregate that has the correct status. And yes, we can see the controller too, where we have this, order ID changes. So our front end can register using SSE to this, let me call it streaming of data, and when an event occurs, then we publish this event using server-side event channel that is opened, and it is totally implemented in HTML, so we can use it both in front end and in back end with basically any framework, because it's kind of standard. And in the front end, of course, we read these changes and we know if we are publishing, this one, if we are publishing an order updated event or if we are publishing another one. We have a few minutes left, and I would like to show you, we implemented also a policy, but I leave this to you to see if you would like to see it. And I will go to the last commit, where we come to the end, basically. So what happens when you would like to know how is your structure? We created a test that is documentation. Okay. And this test basically uses Modulith to create the structure of your module, and it writes a UML with your module, and I can run it. And if it works, it worked. In the target folder, we will have Spring Modulith docs with this. Just a second. Close other tabs. Okay, it doesn't work. Why? Oh, probably for this. Okay. Oh. It worked. So we can see this document that basically it's a simple version of our documentation with the relation between modules. So you can see that attendee, for example, depends on shared modules, and you have some interesting information here, like application layer, find attendees, and also the implementation. This is an interface. Yeah, you can see. We have this event logger and so on. But yeah, we have to come back to
Okay.
the presentation. I'm going to finish it.
Just a few takeaways. Do you remember when I started saying that when we have a microservice, we have a lot of things to orchestrate, and we have to decide who is the owner of what? And when we have a monolith, basically you don't know who is the owner of something. Well, in this way, as we've seen right now, we can decide who is the owner. It is clear who is the owner, and we have some boundaries. After we set the boundaries, moving from a modular monolith to microservices is just something that we can do when needed, because we already have boundaries. and the boundaries will decide, the modules will eventually become a microservice. Okay, so this make it very easy to evolve a modular monolith into a microservices set. We have DDD that help us to recognize the boundaries, because we've seen that session is a boundary and the attendee is another boundary. So we have some rules that helps us to recognize and decide how to create the modules and set the boundaries. We have a maintainable and understandable architecture, because the tests helps us to design it and put the code in the right folder, in the right package. Also, we have some documentation, not just the documentation that Modulith generated, but the tests that validate the architecture, tell us where to write the right code. And we can describe it, we can code it and test it, and it's just up to us to decide what's the kind of architecture that works for us. We decided to use a layered architecture and wrote some tests to validate it. But you can decide to use, for example, an hexagonal architecture. You can write tests to validate that too. So just find out which one works for you, write some tests, because they will validate your architecture now, but your architecture tomorrow, and so on. If you are curious to use and find out other things and experiment, this is the repository. So you are basically done, and the time is up.
Should be okay, public and everything.
Let us know if it's not public. It should be. It works. Okay.
Perfect. Thank you for the feedback.
Thank you.
Thank you.